Newer Glenn is here. New Glenn comes in from port and everybody's happy. It's a great day. New Glenn is home, getting ready to fly again in 2 months. And then out of the blue, Blue Origin tweets out this plan for essentially the block upgrade of New Glenn like that. And starting on the next flight, they're going to start instituting changes to the vehicle. There are now going to be 2 variants of New Glenn. We're going to have the 7-engine first stage variant and the 9-engine first stage variant, and also the variant with a 2 and 4 BE3U engines for the upper stage. This is going to add incredible capabilities for New Glenn that is going to be hard. Outside of Starship, nobody can really get close to what these capabilities are. I thought I'd run through what their announcement was this morning and then look at how we're going to potentially see some immediate applications for even the Artemis program, let alone all of the private opportunities that will be coming their way. Blue Origin has announced a series of upgrades to New Glenn designed to increase payload performance and launch cadence while enhancing reliability. The enhancements span propulsion, structures, avionics, reusability, and recovery operations, and will be phased into the upcoming New Glenn mission beginning with NG3. That's in 2 months. One of the primary enhancements includes higher performing engines on both stages. Total thrust for the 7 BE4 engines is increasing from 3.9 million pounds of thrust to 4.5 million pounds. BE4 has already demonstrated 625 pounds on the test stand at the current propellant conditions and will achieve 640 pounds of thrust later this year, with propellant subcooling increasing the current thrust capability from the existing 550,000. So essentially, they are cooling the propellant down, chilling the propellant down even more to cram more performance out of the engine. And another benefit of the super chilling of this propellant is that it will become denser, and they'll be able to cram more in those tanks. So it'll burn more, and it'll be kind of a push in terms of how it'll burn more propellant. So okay, you add more propellant to the tanks, but you're burning more, so it's going to be kind of a push in terms of how long the burn will last. But that's going to be a significant thrust improvement. The total thrust of the 2 BE3Us powering New Glenn's upper stage is increasing from the original design of 320,000 pounds of thrust to 400,000 pounds of thrust over the next few missions. The BE3U has already demonstrated 211,000 pounds on the test stand. These enhancements will immediately benefit customers already manifested on New Glenn to fly to destinations including low Earth orbit, the moon, and beyond. And you might be thinking, okay, well, they were already going to be flying there. Like, what's the immediate benefit? So the current version of New Glenn, yes, could carry the manifest could get its soon to fly payloads to their destination orbits. We knew that. So what is the advantage of more thrust? What is the advantage of increased performance? Well, oftentimes these satellites need to carry their own propellant to get themselves into like a final orbit, right? So the booster will get them to a parking orbit, we'll say, and then the satellite itself will get it to its final destination, the last mile, right? Well, we saw in the last flight that the second stage of New Glenn hit a bullseye in terms of where it was supposed to finish. The BE3Us have displayed really wonderful capabilities in its throttle ability. They can deep throttle, so they can be super precise on where they can deploy their payloads. If you can get your payload to its final orbit, now that payload can carry more propellant. Well, that propellant was planning on carrying will last longer, essentially. So it's going to have an immediate benefit to their customers. These enhancements will immediately benefit, will immediately benefit customers manifested on New Glenn to fly destinations including the Earth orbit, the moon, and beyond. Additional vehicle upgrades including reusable fairing to support increased flight rates. Huge bonus. An updated lower cost tank design and a higher performing and reusable thermal protection system to improve turnaround time. The next chapter in New Glenn's roadmap is a new super heavy class rocket named after the number of engines on each stage. New Glenn 9x4 is designed for a subset of missions requiring additional capacity and performance. The vehicle carries over 70 metric tons to low Earth orbit. The next closest vehicle is the Space Launch System at 90 tons in terms of greater, and a completely expendable Falcon Heavy, I believe, is rated for 63 tons. So this is a reusable, super heavy lift vehicle at 70 tons. Starship can allegedly do 100 tons to orbit. and two in a reusable configuration, at least the first stage reusable, and an expendable can allegedly do 200 tons to LEO. But that's, still, there's still quite a bit of work there, but not that I doubt that it's going to happen, but Starship is still actively being developed, where this vehicle is developed, it's done. At least the 7x2 variant. Additionally, the 9x4 vehicle will feature a larger 8.7 meter fairing. Both vehicles, 9x4 and our current variant, 7x2, will serve the market concurrently, giving customers more launch options for their missions, including mega constellations, lunar and deep space exploration, and national security imperatives such as Golden Dome. What I'm a little curious about, and chat, I'm curious if you have thought about this too, is I wonder if it's even worth having a 7x2 variant and just having like a 9x2 and a 9x4, just in terms of central. I know that they've done the math on this, so there's obviously a business case here, but it is certainly fascinating that they're keeping two different boosters, which will have a lot of common core components. I mean, the engines, the propellant tanks appear to be the same diameter, so they'll be able to use the same tooling or similar tooling to build the vehicle. But you would think in terms of, reduction of multiple assembly lines, you just create one booster and then two different second stage variants, similar to what United Launch Alliance does with their Vulcan and Atlas class of vehicles. They have a bunch of different second stages, and they have the same core stage, but they're basically the difference between the Vulcan core stages is you can just have it clean, or you can add essentially up to 7 solid rocket motors to it. It'll be interesting to see why they've done this. Maybe they're just so far down the path of the 7x2 and it works. So it's great. Asteroid says, I think the Starship target is 150 and 200. I mean, I would believe that. When do I think NG3 will happen realistically? I think late February. Can the current launch mount handle it? No. This 9x4 vehicle is going to require its own launch site. It's still a little unclear if it's going to be horizontally integrated. This is a really big rocket, and all of the renders have shown it next to a tower. We do know that Blue Origin is building a new vehicle assembly building that is going to be 50 feet taller than the current VAB. Think about that. We know how big NASA's vehicle assembly building is, and they're building their own that is going to be 50 feet taller. So that speaks to me that they're likely going to be doing it's going to be vertically integrated, vertically stacked, and then crawled out to the pad, similar to SLS, or similar even to Starship. Starship is not crawled out to the pad completely stacked, but at least stage 1 and stage 2. And maybe it might be a bit of a hybrid similar to Starship. Maybe stage 1 comes out to the pad and stage 2 separate, and they host it and they mount it there and send it out. A lot of options on the table here. And this was the site that loaded minutes before the stream began. And in the title of the stream, I'm like, this is targeted at Starship. When you hear my logic, it's going to make a lot more sense. We've talked about a lot of this. It's nearly 400 feet tall. It's only a couple meters shorter than Starship V3. Like, this thing is, and from a height perspective, they're 1-to-1, where you're primarily looking at differences is girth, diameter. I mean, Starship is like almost twice as wide in terms of its diameter, I believe. Infographic Tony, why build one when you can build two at twice the price? Yeah. The 7 engine variant and the 9 engine variant, I'm not totally sure. If I would expect that they'll eventually like maybe cap the 7 engine variant and then, keep scaling the 9 engine variant. And it's interesting when you look at the 9 engines too, it's quite interesting. Anyways, I've got some other thoughts on that. So we've looked at, this is a new render here. Look at this fairing. Now let's look at this render really quick. And there's actually, let me see if I can actually, immediately we can see that the fairing kind of cups out. It's going to be similar to like a Falcon 9. So the fairing is going to be wider than the diameter of the vehicle. We see the 9 engines. Hello, but look here. What do we have here? This is like a Falcon 9 style landing leg. We also see here like some curvature. It looks like some kind of like swing arm, still undetermined, but it's next to a tower. So what this tower's role is still a little undetermined. Looks a little like the LC-39's tower. The fins are larger. It's a larger vehicle. So the chines. So what's also interesting here, and there's another render here, there's actually quite a bit of spacing in here. When, now we're getting a little spoiled with what Starship's done to us in terms of engine density and what they've been able to cram in there. I think that they could squeeze more engines in here. I think they could. What's interesting with this design choice with the new legs is now the legs are completely on the outside of the vehicle rather than inside. So therefore the thrust structure down here has more room for more engines. Now the legs are on the outside. And this is admittedly a much simpler design, pioneered by SpaceX for a reason. There's very few moving components to this. When you look at the current landing leg configuration, there is a lot of moving parts, and it's inside the vehicle, and they've made that choice to reduce the drag, but it comes at a cost, right? You can't use that thrust structure for engines. So now they've moved them to the outside, and now they have more room for engines. And the way that these landing legs work, just to kind of quickly review, they're very similar to Falcon, I would assume, is that they're pulled up and they're basically under pressure, and there's like a latch on the top. And as soon as the latch detaches, it's largely an analog system. It's hydraulic, presses down the leg and locks it in place. And then there is a crush core that, as the rocket comes down and touches down, the crush core absorbs any impact and allows that impact to be transferred to the crush core rather than the booster structure. And that crush core gets tossed. They swap it out, snap the legs back in, and that's pretty much it. So the crush cores on Falcon 9 are disposable. I want to make sure I'm looking at chat here. Yeah, look at the legs on the render. Yep, happy you're pointing that out. Pashto, thanks, I hate them. Random says they can definitely fit in 3 central engines. I mean, I think that there's room. You could do 3, you could do 4. 1, 2, 3, 4. Now, when you add more engines in, it reduces your gimbal ability. That's a trade-off, but do they need that extra gimbal authority? I don't know. Starship moves them all very effectively. There's the outer, engines could be static. Yeah, the center engines need the room to gimbal, but do they need that much room? They could be creative. Now, super smart folks over here. I'm just trying to take it to the next level. Befrey Jesus, if you're watching the stream, 5.7 million pounds of liftoff. So like, take a look at like they've got these guys in pretty tight. I'm feeling pretty good about more engines in here. So, but also just look at the diameter here. The 9x4, so they call this the 9x4. So they call this a 9x4 because rather than in the current variant, it has 7 BE4 engines and 2 BE3U engines on the second stage. This one's going to have 9 on the first stage, 4 on the second stage. The 9x4 is reusable. First stage is designed for a minimum of 25 missions and will be powered by 9 BE4 Block 2 engines. They will generate over 5.7 million pounds of combined thrust, 50% more than New Glenn's current first stage. That's a lot more. And also for a point of comparison too, although the Raptor 3 is a incredibly powerful engine, especially for its size, this new block of the BE4 does create more thrust than Raptor 3. And now Raptor 3 is still they're still gonna squeeze out more performance, and I believe that there's still a lot more room in the BE4 from folks I've talked to. There's a lot more room to grow in the BE4. So what we're looking at here is not the finish line. It's only the beginning. So we're moving on to the second stage here. Powered by 4 BE3U engines, the second stage carries 70 metric tons to low Earth orbit, 14 metric tons to geostationary orbit, and 20 tons to TLI. The second stage engines generate over 800,000 pounds of thrust, more than 100% of New Glenn's 7x2 configuration. So this here, when we're talking about these payload numbers, this is where we're starting to touch some Starship SLS territory here. Infographic Tony, he said, just checked only 3 gimbal on the 7-engine variant. Thank you for that. I have my Snoopy cup. It's getting close to Christmas time here. Look at that, man. That is just simply gorgeous. And this gives you some idea of the scale here. We're talking about 7x2, just shy of the Saturn V, for those of you who have seen the Saturn V in person at the museums. And New Glenn 9x4 is a honker. And the payload fairing is just going to be huge. The 9x4's addition to our fleet supports demand for larger commercial mega constellations, lunar and deep exploration, and lunar and national security missions. A visual comparison shows a progression from the 7x2 config with the historic Saturn V shown for scale, which, as we know, is a Befri Bezos favorite. They also show the tower on the side here. It's still quite nondescript. It looks a lot like 39A. I mean, it's not a carbon copy, but it's very similar. Does LC-36 have sub-chilling capabilities? Great question. I don't know. We're likely not going to see this 9x4 variant for like 2 years. So there's still ground infrastructure that needs to be. To Rhodey's question earlier, I'm curious about the flame trench. Can that support New Glenn 9x4? Because if it's just a matter of swapping out the launch mount, then they're in a much better place. But this tower is an interesting thing that they keep incorporating in the renders. This will be something to watch. Learn how 9x4 can meet your mission needs. So people have been doing some back of the napkin math on this vehicle, and it is, when we look at the fairing size, it's actually quite just pixel peeping right now. It's quite comparable to the fairing volume of a Starship. It's very close. And if the industry is going to be moving towards optimizing payloads for Starship, then that's immediately going to put Falcon 9, Neutron, other medium lift capable vehicles, or at least that's going to make it harder for them to compete, especially in the Constellation class of payloads. So if a company is optimizing their Constellation deployment for Starship, and we have another competitor here who has a very similar fairing size, now there's two immediate potential providers. So by them making these upgrades, they're immediately going to be putting themselves in a competition space of Starship. In terms of its role with Artemis, Starship, we know, is HLS, right? They have not shown any interest. SpaceX has not shown any interest in adapting Starship for the current Artemis infrastructure, regarding SLS and Orion. Orion was designed and is designed to be booster agnostic. I mean, they'll have to make some modifications to the software, but it's technically supposed to go on several different boosters. It's flown on 2 different boosters, SLS and the Delta IV Heavy. It's not actually that far-fetched of an idea that you could put Orion on top of this New Glenn 9x4. Now, this 9x4 in of itself cannot throw Orion to the moon. It can get it in Earth orbit, but it cannot get it to the moon. But we're only seeing numbers in a reusable configuration. Now, Orion, you would strip down the fairings. You wouldn't have these fairings on here. And potentially, there's several options on the table for getting Orion to the moon, leveraging the New Glenn architecture. And let's just kind of kick this around a little bit. So you could potentially have an expendable New Glenn. Now, that's obviously not what they're really building the New Glenn 9x4 or 7x2 for, but you could save a lot of mass by having it expendable. So perhaps you're able to squeeze out some more performance out of the vehicle and get Orion in a better orbit. And then Sonderax is asking now, what about the 3rd stage variant? And that's something that's not covered in these renders. There is a 3-stage variant of this New Glenn that we're not super clear on what its performance numbers are. Now, that variant could throw it to the moon potentially. We don't know yet. There's a lot we still don't know, and the more people start crunching numbers and we get more information out of Blue Origin, we'll get a firmer picture. But the third stage variant with the kick stage might be enough to throw it to the moon. Let's just work with what we know, though. So okay, maybe an expendable version, but I doubt that that's going to get it to the moon. But what if you launched a New Glenn with no payload, it's just empty, and you had the 2nd stage parked in orbit? That's basically topped off. Orion rendezvous with it, and that does the TLI burn and gets you to the moon. Because Orion can get home from the moon. You got to get it there. We don't want it to spend any propellant around the Earth like it's doing with Artemis 2. That's a huge waste of time and resources. So maybe that's on the table. The other option that's on the table, and actually let me pull up a picture of it, the Cislunar Transporter, which they are making for Blue Moon. And the whole idea is this vehicle is parked on orbit, and it's refueled, and its entire job is to be a tug between the Earth and the moon. Does this have the Delta V to get Orion to the moon once you're in orbit? Possibly. It's an option on the table, or an upgraded version of this. They're building this architecture out, and this vehicle is designed to not have any boil off of its hydrogen propellant, hydrogen and oxygen. It's using both passive and active measures to keep the vehicle cold. So this is also an option that Orion would rendezvous with this, and this would do the burn. This would do the TLI burn. So there's a couple different ways already to kind of see how New Glenn could be used in place of SLS. Now, SLS is going to fly for a couple more missions. I believe it's Artemis 5 we're good for. So I'm not saying it's going to take the role of SLS immediately. I mean, this new vehicle is not going to fly for at least 2 years. The 9x4 is not going to fly for at least 2 years, likely 3. But it's going to be progressing way faster than SLS Block 2 or 1B. So, you know, and it's going to be much cheaper than the Space Launch System, which is clocking in at like $4 billion a launch. So for a fraction of the cost and potentially using a reusable configuration, and we got 2 of them here, NASA might be able to get Orion to the moon using Orion and it's in the exploration in the European Service Module. So it's really worth considering. You fly out the existing SLS fleet. I'm not saying anything that's built or currently under construction you pause, but it's really worth considering. So Starship is great. Like, don't get me wrong. Like, it's going to offer a lot of capabilities that New Glenn cannot. But we're seeing some very interesting work out of Blue Origin that we have to give them a lot of credit for. They're improving the capabilities of their engines. They are moving to where there's this saying, like, you don't want to go where the puck is. You want to go where the puck is going, right? When you're playing hockey. And they're doing that. In a contrast of like a ULA, I mean, I don't know where they're going, but it's not where the puck is going right now, at the very least. They've got warehouses filled with Vulcans. They're not flying. They have not shown much interest in reusability. Now, they do have contracted a crazy manifest of like 50 launches, I think, for Vulcan or something like that. Thing's going to fly. But when you have a competitor like New Glenn, that's flight cadence is really going to be increasing. Like, are you going to get more? So they need to radically change how they're thinking. Benefit for them with Vulcan, I would think, is that these BE4 improvements potentially are going to also improve Vulcan, but I don't know if they're going to be able to provide the supercooled propellants in order to capitalize on that. I don't know the answer to that question. Maybe somebody in the chat knows. There's a lot of options on the table for New Glenn, and the fact that it landed on its second attempt still blows my mind. Really, really does. I do want to give credit to Dave Limp, the CEO of Blue Origin here. I know we talked about him last week, but man, really, the fact that they're being so customer-centric here, that we know that satellite constellations are the future in a lot of ways. And from a cost per unit perspective, you want to fly them on these super heavy vehicles. You can get more payload you can get more satellites to orbit on a single launch, therefore reducing the entire cost overall on the program. And now there's going to be 2 players in the game, Starship and New Glenn. And that's really where it's going to be moving, especially when we're talking about all this interest in moving data centers to low Earth orbit for energy reasons. Like, you're looking at this, you're not going to want to put, 12 supercomputers on a Falcon 9 when you could put 40 on a New Glenn or Starship. It's also going to be interesting to see how they adapt their Kuiper, or what are they calling it, Amazon Leo satellite constellation for these new capabilities. I think that they can fly, man, we looked at it last week. They can fly like maybe 50 or 60 of those satellites on an existing 7x2, but on a 9x4, it's going to be a lot. Infographic Tony says, I was blown away at the precision landing and deck weld on Jacqueline. So cool. It nailed it. It couldn't have been more dead center. I'm still very curious about the welding aspect and the damage it does to the deck, or no damage. I don't know if anybody at NASA Spaceflight got any imagery of that. Infographic Tony, was the deck weld a surprise? No, we knew that was coming, but what seeing it for me was kind of shocking. I don't know why. And then I immediately went to, how damaged is the deck? I don't know. Sondrak says, if they can offer transporter-esque missions, they'll sell out fast. 70 tons to Leo, payload volume similar to Starship, could be several hundred CubeSats. Yeah. And the transporter flights we're seeing more and more of. The challenge with those is making sure that you're going to an orbit that people need, right? Not every satellite is going to an equatorial orbit, let's say. From what I understand, the pins which they weld down can be separated from the legs. Simply lift the vehicle, leaving the pins, then cut the pins off. Yeah, that's what from looking at the patent. Now, the patent's not precise as to exactly what the design is, but the idea, it seemed like that was the way it would work. This vehicle, though, another thing, like to say the quiet part out loud, is it's probably going to put to bed, once it's operational, put to bed the Falcon Heavy. Because Falcon Heavy in its max out configuration that they've been flying, they're still expending the center core, and it's not as capable as the New Glenn, which will be reusable and therefore will likely be a cheaper booster if they get the flight rate up. So Falcon Heavy does have more launches on its manifest, but maybe we'll see some customers when they're planning into 2028, 2029 timeframe. They're going to be looking at this new variant very closely.